So number 5 on the final exam is asking you to find the interval of convergence for a given power series. And it gives you x plus 8 to the n over n times n plus 1 times n plus 2. So let's go ahead and let's try to figure out the interval of convergence. So if we want to find the interval of convergence, first off we need to find the radius of convergence. So let's start by doing that. So the way we do that is we usually apply either ratio or root test. Again, for the sake of just simplicity, I'm just going to apply ratio test because that's the one that should work every single time. So limit as n approaches infinity of absolute value of a sub n plus 1 over a sub n. So remember, to get a sub n plus 1, anywhere I see an n in here, I'm going to plug in n plus 1. So I have x plus 8 to the n plus 1 divided by n plus 1, n plus 2, n plus 3. That's going to be times the reciprocal of a sub n. So a sub n is just this series here, and because I'm dividing by it, I can multiply by its reciprocal. So I have n times n plus 1 times n plus 2 all over x plus 8 to the n. I'm going to close my absolute value bars. So if I look, I can actually just start canceling some terms out. This n plus 1 drops out with this, n plus 2 drops out with this. So I am left with an n over n plus 3, and I can cancel out this x plus 8 to the n, x plus 8 to the n plus 1. Remember, if I have terms of the same base with added powers, I can always split them. So I can take this x plus 8 to the n times x plus 8 to the 1. So now this term cancels out with that term. So now all I really need to find the limit for is I need to find the limit for x plus 8 times n over n plus 3, with me taking the limit as n approaches infinity. So when I have n over n plus 3, when I take the limit of that as n approaches infinity, it's actually indeterminate. So what I can do is I can derive the top and derive the bottom, and when I do that, this ends up going to 1. So remember, polynomial terms of the same power as n approaches infinity, it goes to the limit of whatever their coefficients are. So in this case, I end up just getting 1 for this entire series times x plus 8. So this ends up becoming absolute value of x plus 8 is less than 1. So now I have my radius of convergence because x is to a first power and a 1 coefficient. So now r is equal to 1, but I didn't really need to declare that. I'm just going to set it off to the side there, make sure that I do know what it is. Now I need to find my interval of convergence because that's what I'm really interested in. So to find my interval of convergence, again, I know that this should be between an interval of -1, x plus 8 is less than 1. And that's from, again, I can take the radius, and I know that it should extend to a positive and negative value on either side. Now all I have to do is get x by itself, so I end up with -9 is less than x is less than -7. Great. So now there's one last step that I have to do. I have my interval, but now I need to test my endpoints. So every value inside of here should cause this series to converge. But I don't know what's going to happen at my endpoints. So if I go ahead, and I'm going to clear myself a little more room here, what I'm going to do is I'm going to take my endpoints, so I'll set it up side over here. I'm going to test my endpoints and see if I have to make them exclusive or inclusive. So I'm going to plug in -9 first. When I do that, I end up with n equals 1 to infinity of -9 plus 8 is -1 to the n over n times n plus 1 times n plus 2. So this is now an alternating series. So I can go ahead and I can apply alternating series test to prove whether it converges or diverges. So alternating series test, the first criteria says that the limit as n approaches infinity of b sub n has to be equal to 0. Well, my b sub n in this case is 1 over n times n plus 1 times n plus 2. So if I take the limit of that as n approaches infinity, the bottom is growing faster than the top, for sure. So this is definitely equal to 0. So it satisfies this first criteria for alternating series test. Second criteria says that b sub n plus 1 has to be less than or equal to b sub n, which just means that overall it has to be decreasing over time. If I have b sub n plus 1, to find this term, what I'm going to do is I'm going to take my b sub n and I'm just going to plug in an n plus 1 for every n term that I have. Now what I'm going to do is I'm going to compare it to b sub n, n plus 1, n plus 2. So in this case, again, remember, I can actually cancel some terms out here. So what I'm really looking at is I'm trying to figure out if is 1 over n plus 3 less than or equal to 1 over n. Well, this denominator is larger than this one, which means that the fraction should be smaller. So this is, in fact, decreasing over time. So it satisfies this second criteria as well. So that means that for negative 9, I write brackets around it. Now, my next step, n equals 1 to infinity. Now I want to plug in negative 7, so I end up with 1 to the n, which 1 to the n for all n is always going to be 1, but I'll go ahead and just write that for now. So then I'm just going to write my bottom like normal, n plus 1, n plus 2. So this is just 1. So I'm trying to figure out if 1 over n times n plus 1 times n plus 2 is convergent or divergent. Well, there's a couple ways we can do it. What we could do is we could do a direct comparison test in this case. So if I set up my direct comparison test, I think because this is going to be like an n cubed power, I think I can prove that this will be convergent. So I'm going to put this as my a sub n, because I do want to prove convergence. And I'm going to say that that's going to be less than or equal to, so I need to pick something that will always be greater than this fraction. So what I'm going to choose is, I'm actually going to say that it's greater than or equal to 1 over n cubed. So when I look at this denominator is larger than this, so this inequality should hold true for all n. Now, to prove that this series is convergent with direct comparison test, all I have to do is prove that this is convergent. If the larger series is convergent, then this should be convergent as well. 1 over n cubed is convergent by p series because 3 is greater than 1. So therefore, convergent by p series. So because this is convergent by p series, this should also be convergent as well. So what I actually end up getting is that no matter what value I plug in for either of my endpoints, they are both inclusive to the series. So now if I actually look at the answer key says that it's D, but that's actually incorrect, it's a typo. The real answer should be letter B.
The Teaching Center, UF's Learning Resource Center.